Welcome to Solutions Studio. This is a free series on C programming language. If you like these videos, please subscribe to follow along with this series. Also, please like and leave a comment and share the video to help spread this series. Hello and welcome to this episode, and in this episode we discuss about bit fields. So what is exactly bit fields? So bit fields is a feature that we can specify for the members of a structure so that how many bits each member of the structure can get from the memory. So here in this structure bit card we have three members. Each one of these members, they are unassigned integer. They could be also signed integer, and basically bit fields only work with integers. We cannot assign bit fields with other type of data types, only with integers, either unassigned or signed. And we have these three members: face, suit, and color. We have specified 4 bits for face, 2 bits for suit, and 1 bit for color. And how do we specify it? Using this colon in here, and the semicolon will go at the end of the statement after the bit field. And as you can see, why we have specified 4 bits for face, because the face of the card can have a value of 0 to 12, 0 for ace up until 12 for king. For the suit of the card we have these 4 values: hearts, diamonds, clubs, and spades. And for the color of the card we only need 1 bit, that could be either 0 or 1, 0 for red and 1 for black. Basically, with this amount of memory, 1 plus 2, 3, 3 plus 4, 7, we will be able to represent the full deck of cards. And why do we use bit fields? Because bit fields, as we said before, they help us specify the amount of memory that each one of these members take. And when we specify the amount of memory, we are making better use of the memory. So instead of this integer, which might take 32 bits, so this integer, which might take 32 bits in a 32-bit system, it takes only 4 bits in here. And this way we are making a better use of the memory, or we can say that we are striving to use the minimum amount of memory required. And that's it for this episode. I'll see you in the coming episodes where we will be using this structure in an example, and you will be able to see the efficiency of bit fields. Stay tuned. Hello and welcome to this episode, and in this episode we want to have a demonstration of this structure bit card that we created in the previous episode. So you know that in the previous episode we created this structure and we also set the bit fields for each one of the members of this structure. We determined that the face member will take 4 bits, the suit member will take 2 bits, and the color member will take only 1 bit to store the data that is needed to store the specification of a card. Now in this program we want to use these members to be able to see which card we have stored in one of the objects that we have created from this structure. So here we have created an object of this structure, my card, and we have also initialized the values for the members. So we have created this program using these switch cases, as you can see in here, to tell us that what card we have stored here exactly in the object that we have created. Let's go and run this program. And as you can see, it's telling us that your card is ace of diamonds in red. So that was an example of how we can store any card within this structure a bit card. For example, let's go and change some values here, maybe 1, here 2, and maybe here 11. Let's go and run the program again. And our card is Queen of Clubs in black. Let's close this program. Now we want to find out how much memory did we use for creating this object myCard. For that, we have this size of operator. As you can see in this printf statement, we have applied the size of operator on the object myCard, and we want to print the value. Let's go and run this program. And as you can see, the size of the object that we have is 4 bytes. And even though we have 3 integers inside of this structure has only taken 4 bytes. Let's assume that we remove the bit fields. Now each one of these members will take the standard integer memory requirement that is on this system. So no bit fields are assigned at this moment. And now if I execute the program, you can see that the size of this structure is 12 bytes now. Now you can see how much difference does it make when we use bit fields and how efficient bit field makes our programs. And that's it for this episode. I hope this has been informative for you, and I would like to see you in the coming episodes. Stay tuned. Hello and welcome to this episode, and in this episode we discuss about unnamed bit fields. We have discussed about bit fields in the previous episodes and how and why do we use bit fields. So if you want to know more about bit fields, refer to the previous episodes. Now in here we discuss about unnamed bit fields. In here you can see that we have this structure example. It has 3 members, A, B, and an unnamed member. Why do we have this unnamed member? This unnamed member helps us to create a padding in memory of 3 bits. So this unnamed memory will create a padding. That means that this amount of memory after A is assigned inside the memory, this amount of memory cannot be used and it's going to be reserved as padding. And B will be stored after these 3 bits of a memory. Now here I want to show you how exactly would it look like inside memory. Suppose that this is our memory. It starts from address 0, 1, 2, 3, 4, and you know that we have this member A which takes 5 bits. So these 5 bits are going to be used for this A, for the member A. After that we have the padding. So the memory location 5th, 6th and 7 is going to be used as padding and cannot be used, and nothing can be stored in those memory locations. And after that the computer will use the rest of the memory bits for storing B. So B will be stored in this spot. And we can also have an unnamed bit field with 0 with length. So instead of 3, we would put a 0 in here. And this aligns the next bit field on a new storage unit boundary. That means that if we have a 0 in here instead of these 3 bits, any other bits that are going to come after this chunk of memory, this unit of memory, any other bits, all of them are going to be used as padding. So anything after that is going to be used as padding, and B will be stored in a new And that's it for this episode. I hope this has been informative for you, and I would like to see you in the coming episodes. Stay tuned.